welcome. First of all, thanks a lot for joining this session with Fluendo. I am Alberto Gómez. I am Business Unit Manager of Fluendo. In this case, we are presenting a very important topic, which is privacy preservation in real time for broadcasting. So welcome to Protect What Matters, Real-Time Anonymizer for a Safer World. The presentation will be split into four main sections. First, when we are going to introduce Fluendo, what we will do. Then we will jump to the problem statement, so basically what we're trying to tackle. Then we'll jump to the technical section of the call, how we are basically achieving the performance we are getting, and then finally we are going to draw some conclusions. So we are Fluendo. We are a company based in Barcelona. We are a small medium company, 35 to 40 people, and we are multimedia engineering experts. We have been always related to GeoStreamer, which is an open source multimedia framework, basically the standard de facto for building multimedia applications, and we provide to several clients SDK, streaming plugins, and AI components. In this case, the anonymizer we are presenting is AI-based. Since some years ago, we are also doing AI. Here you can see some of the clients that we have. Very important clients like HP, Dell. We have partnerships with research institutions like Fraunhofer Institute. So this is the relations we have built during these 20 years. We offer basically our main line of business. It's codecs. So we build codec packs for thin client manufacturers, some laptop manufacturers as well. Then we have also the division of services. In this case, we are offering services for B2B, in this case, to other businesses with the engineering expertise that we have. And finally, we have also our R&D division, which this anonymizer was taken from. So let's jump to the presentation directly. So what we are going to try to tackle. So in this case, what is anonymization? With anonymization, what we want to do is basically to try to preserve the identity of the people by basically blurring or pixelating or removing the facial identifications of the different persons, especially, for example, on vulnerable clubs. So the first pillar that we are going to present is that basically we want to protect the identities of the people. The second one is, especially in Europe, you can see that, or you may know that it's very, very important, the adherence to privacy regulations. GDPR are very strict and will become stricter, even more strict in the following years, basically to preserve the identity of some individuals, especially on vulnerable groups. But here the important thing is we want to do this preservation of identities. We want to adhere to the GDPR compliance, and we want to do it real time. So basically, that is one of the problems that we have right now, that there are no systems that can basically do that efficiently in real time. Most of the systems right now rely on on cloud systems. The drawback of cloud systems for anonymization is that it basically requires high bandwidth. It requires a very stable internet connection to basically send the video to the server, process it there on the server, and then send it back to the client. And then that includes a high latency related to that. On the contrary, that is a good thing about server computing, is that it basically allows to deploy very complex models, AI models. On the contrary, on Edge, that is the solution that we are going to try to provide. It's basically that everything stays on premise. You can do it real time because the processing it's on premise. There is no network connection required, and basically the drawback is that you need to have simplified models. But by our engine, that in this case is Raven AI, that I will introduce later, we basically allow and try to tackle these issues. So we provide with Raven, with our technology, the edge computing in a very efficient way. So what is Raven? Raven is our own proprietary engine, in this case, that basically we have developed for more than 3 years ago, that it brings several benefits. First of all, is that it's multi-hardware. I will enter into the detail later what multi-hardware means, but we can run on any GPU most in the world, the most famous ones, which is NVIDIA, AMD, Intel. We're accelerated also for Vulkan, DirectX. So we are on a layer that is above that. It's also multi-OS. We have acceleration for Android, iOS, Mac OS, especially Windows. We are proficient in Windows right now, and on Linux. And the thing that we are presenting here is that our own engine allows ultra-fast performance, and that means real time. So 0 milliseconds latency, close to 0. We have made some calculations, some tests, and it can process up to 500 frames per second, which is impressive, at resolutions up to 4K. If we want to be prepared for the future as well, and we are incrementing these resolution capabilities, going up to 8K, 16K, or preparing for the future as well. So how do we do that? That's the most important part of the talk, right? About Raven. So here on the top, you can see conventional AI pipeline, and then you can see on the bottom part, full GPU-driven pipeline, which is ours. Conventional pipelines usually basically have two components, right? When you are doing an AI pipeline, you have the CPU, and then you have the GPU. Here we have done on the top part, the black part that you can see in the presentation is basically the GPU, right? So GPU is doing some calculations, some graphical calculations. They are drawing some textures, whatever. They are doing GPU operations. Then basically the problem is that it needs to wait for the CPU to do pre-processing of the AI. Then it needs a synchronization between GPU and CPU. So all the information is basically stopped, and GPU is doing nothing during that time. So we have GPU operation, then we go to CPU. We wait some time in the GPU without taking advantage that the GPU can do something, right? And then the systems go down again to the CPU, then go down for the GPU to do the inference, then they wait again for do the post-processing. So basically in Raven, what we do is we draw the set of instructions at the beginning, we send from the CPU to the GPU, and all the processing is done directly on the GPU. And then we take advantage of all the pipeline that can be drawn in parallel. We do at the same time, we do processing, we do pre-processing, we do the inference, we do the post-processing, and we do the draw of the textures as well, everything in the GPU. So powerful of it is that we are building a new scenario here in which these synchronizations between CPU and GPU can basically be erased, and we can run everything directly on GPU base. This is why we achieve this ultra-fast performance. So now, going to some numbers, comparing exactly the same model that we have for Anonymizer in our Raven engine, and then the other standard that most people is using, which is Python plus OpenNX, and we're achieving frame rates. This is for the full pipeline of decoding plus Anonymizer plus encoding plus visualization of 236 frames per second, and exactly the same model. You can see that it's 3.6 frames per second in Python. So actually, real time can only be achieved in this case with Raven. And then a comparison, you can see on the right part of the presentation, a table of comparison, and on two of the main competitors, let's say, on AI engines in the world, which is NVIDIA DeepStream and Google MediaPipe. You can see that on OS, our plan is basically to support everything. So here we have that DeepStream can only work in Linux, in their systems, right, NVIDIA. So they basically are implemented for their graphical cards. And then MediaPipe is Linux plus Android plus iOS. Regarding the hardware, we said we are multi-platform with the hardware and multi-OS, right? So you can see that we can run on laptops, we can run on smartphones. We're planning to run as well on embedded devices. So similar to NVIDIA in this case, NVIDIA DeepStream is running on their graphical cards, right? On NVIDIA PCs and also on NVIDIA Jetson, right? And in the case of hardware acceleration, we support three main GPU controllers in this case, AMD, Intel, and NVIDIA. And then, as we said, we are a GStreamer-based company. We have been contributing for GStreamer for more than 20 years, and therefore, we believe that the integration with the GStreamer is very important. This is why the integration in GStreamer will be fully compatible. In our case, and that is an advantage with respect to Google MediaPipe, which currently doesn't have this acceleration or this integration in GStreamer scenario. And finally, we are in international broadcasting convention, right? So how can this help broadcasting use cases? You may want to anonymize vulnerable people. In this case, we have put, for example, you are a journalist, you want to film directly, you want to stream a live content, you're a TV, you're a broadcaster, and you want to go to a kindergarten, right? So the faces of the vulnerable people, in this case, the kids, need to be anonymized. Unfortunately, that cannot be done at the moment. So with this solution, we can enable that. Also in hospitals, so patient anonymization, public spaces, journalists like courtrooms. So we are protecting here basically the people that do not want or are not, let's say, suitable to be appearing in live streams or live broadcasts. So some conclusions out of this, how Raven is helping this. So basically, today's video demands are going for resolutions up to 4K, 8K, now 16K even, 120 FPS. So the demands for video are really, really high. The demands for live video are basically really high. So we're achieving these 500 frames per second, as we said, by reducing the transitions between CPU and GPU, erasing these contents, and therefore full-driven GPU pipeline, and therefore parallelization and code optimization as well. And finally, the problem statement, if you remember, were two pillars. So the first one was preserving the identity of the people. The second one was adhering to GDPR compliance, and we're achieving that on real time with our technology. So next steps, we of course have a version that is working in Raven. We have a version that is working fully compatible, but we want to continue doing that. Regarding anonymization, so we right now anonymize everybody that is being in the frame at the moment, and we want to basically re-identify these people. This means that we want to select which is the people that is being anonymized and which is the people that is not being anonymized. Imagine that you're a journalist and you don't want the journalist, of course, to be anonymized, right? You want the people in the kindergarten before to be anonymized. So that is something that we will have in our pipeline, and then continue with this optimized support for other backends. We are currently working very good on Windows, and we're working on optimizing it for Linux, Mac OS, and other platforms. Thank you very much. We're in Hall 5, just here, so feel free and come by to see the demo. And actually, we have a webcam, so you can anonymize your face in real time, and you can check that this is real, and we are not. We're basically sending it real, so you have the information there. We're just 20 meters away, more or less.